Good evening again. We have a tight schedule today. The idea is to wrap up what we are doing in these 2 weeks. I'm going to give just a complete overview about the topic in these 2 weeks. You have a lot of reading posted in the classroom, and I expect everyone is reviewing them as much as possible because otherwise attending the course mostly defeats the purpose. Um, so I'm going to start with what we are covering starting for previous week, Hadoop, part of the Hadoop ecosystem, and specifically the practical assignment we are doing with Big SQL. So, and after that, we are going to talk about the current assignment, which I don't know. My perception is going very slow. I don't see many people working on it. I don't see any assignments submitted. At this point, I expected to have assignments submitted and release the next part, which is 3.2, but and let me tell you, this is not assignment to be done at the last moment. It requires time. So still on time, but you have to work. You cannot expect in a course of 6 credits like this, an assignment which is worth 10 or 15 points of your grade to just devote the weekend and done. It's not working this way. So the assignment was for 2 weeks, and the purpose was to work for the 2 weeks simultaneously reviewing the reading. So I'm starting to wrapping up what is in the reading, very in general. Um, the important thing is that we keep in mind there is too much information regarding the topic on these 2 weeks, but we have to keep the general idea why this technology appeared and how it appeared and how it was used and how it's used and what is the future we can perceive. So all this, let's say, important technology appeared because of the necessity of the industry. First was the Google necessity to manage the index of the Google files. Then in 2003, Google published, Jeff Dean published let's say, the seminal paper regarding the MapReduce. They use it, but that was just a scientific paper. Google never never published the code they use it. So the paper is there. The ideas are published, but how they were implemented in Google, that was not disclosed. Then people like Doug Coating took, by the necessity of Yahoo to manage huge amount of information, just in different fashion than Google, they took over, and they actually were the people who published the code of MapReduce and are considered like the father of Hadoop. So Doug Coating is considered the father of Hadoop, naming after the toy of his son at that point. You can read a lot about the history. Here is just a small summary, and you can see how the different company, starting with Yahoo, then Facebook, Cloudera, tried to solve problem by this totally new, let's say, way to do distributed computing. And first thing was the necessity, because all these companies, they needed to solve a huge data problem. Secondly, the technology, let's say, the price of memory, the hardware, the technology at this point already reached some acceptable price to be implemented. And third, of course, we cannot forget about very important element on this, which are some creative minds like the author of the paper and the implementer, we just mentioned it, which were capable to implement the needs based on the existing, let's say, in the point in the stage of which the technology was at this moment. What these people did, they totally changed the idea how to do distributed computing. What happened when the huge amount of data appeared and you cannot, let's say, store in your server the way was before? You just have to scale vertically, and it has to go to some point until your system is going to be so expensive that let's say, not return on investment. In that point, in these techniques, what the measure uses was return on bit was not acceptable. So the idea was, the main synthesized idea was to, since the size of the data is so big, and you have to move even over the faster network, their paper, if you are interested in the calculation, it will take hours to bring, just to move, let's say, 45 terabytes of data, which is normal big data, to move over fast internet, which is, let's say, the base of distributed computing is server connected over network connection. Even with the faster network, at that point, the conception of distributed computing would take hours just to move the data. So the brilliant idea was to bring the computation to the data, which is locality. So the Hadoop idea was implemented by two major elements. First, the distributed file system, which can store, let's say, data in flat file format. We are not talking about here any relational database, any relational structure, just flat data. And doing this by just breaking down the file into blocks with some default format, which is was 64 megabytes, and store the block in across the cluster and bring the computation where the data is. The job to bring the computation to the location of the data is the second component, which is the MapReduce. The MapReduce, like the name indicates, map the computation, group the data of the same cluster and bring the computation to this data. How is this convenient, this totally different idea to do computation, and why it was successful? So it's not so different from a computer science point of view. If we look to Hadoop as an operating system, which the main function of any operating system, you know, is file system and scheduler, which permit to schedule computation on this data. The general idea of operating system always been this in computer science. Just the implementation can be different. So in Hadoop, the implementation is, instead to have the data separated from the computation, bring the computation to the node of data. So you don't have to move this huge amount of data over the network. That brilliant idea is, let's say, the heart of the idea of Hadoop. There are so many resources posted in the classroom and available beyond what we have selected in the classroom. So you have plenty to read and to inquire and to go more on deep. I'm just going to the most important main idea which are behind Hadoop. What this brilliant idea brings in this new solution? This new solution, the first advantage is the scalability. What that means? As soon as your data grow, you can add more nodes and nothing is going to happen. The operating system, the MapReduce, you don't have to do anything. Everything remains the same, just adding nodes as your amount of data grows. So that first characteristic of Hadoop is, let's say, is the first requirement from the problem to solve, scalability. Secondly, you don't want to pay extra high price. Everything is measured bit, let's say, return on bit, how much you return from each bit. So it has to be cost effective, and this distribution was perceived on top each location, distributed location for this chunk of the a file, 64 megabytes, is on commodity computer, very cheap. And all these commodity computers connected together permit this very cost-effective architecture for Hadoop. Another very important characteristic because of this architecture is the flexibility. Since the idea to bring the data in flat file, which is the Hadoop distributed file system, permit a lot of flexibility with the challenges of big data. So big data, we have a big amount of structured, also a lot of unstructured data. Having the possibility to store the data without any schema, no schema like in the relational database. You have to create the schema, store your data, and then start querying the data and processing. Just no schema, flat data, and this gives the flexibility to deal with any kind of data. And in addition, one conception of this brilliant idea was to replicate each data, let's say, 3 times. Why that was needed? For many reasons, and between them, the most important is fault tolerance. If a node goes down, there are at least 2 more nodes with the same data. So you never will lose data. So the most important replication of data gives the very important characteristic fault tolerance. So if we compare this with the well-known relational database, which was, let's say, the way to deal with data until until Hadoop appeared, we're talking about totally different, let's say, paradigm. In the relational database, what we do, we define the schema, and every time we want to add, let's say, a column, just a column to change the schema, this implies a lot of effort. Actually, that was the driving force for Yahoo and for the inventor, Doug Cutting, to go with the idea of Hadoop and to develop and to publish the code of MapReduce. Why? Because Yahoo had this big amount of data stored and queried in data warehouse in the relational database. And every time they needed to do something different, the developer team was asking between all the procedure, all the normal organizational procedure, about 4 weeks just to add a column. And you understand, this is unsustainable to be competitive. So the idea to work with not schema on flat file, which is Hadoop distributed file system, is very inconvenient point of view. What we have in Hadoop, we don't have, we just pour the data, we store the data with no problem, any data, structured, unstructured, semi-structured. So a lot of the data on Hadoop distributed file system is very fast. When the time consumption comes is at the time of read. Of course, at some point you have to have some, let's say, some processing time. There is nothing you can do about this. But for the size of big data, this is the most convenient, let's say, a schema which has solved problem, let's say, in the last 10 years very successfully. So I remember at some point, few years ago, when the hype about Hadoop was in the high, which is not today. Let's talk about 4 years ago, 3 years ago, where the hype thing was in big data Hadoop. Was a claim that this is the end of all relational database, no anymore Oracle, no anymore any other relational database. You have to keep in mind that this is not exactly the story like in many other hype, because the thing you can do in Hadoop with the two components, which is Hadoop file system to store huge amount of data in flat format, and MapReduce, which is the scheduler to permit the processing of this data. If you need to do this architecture is for, let's say, for batch data. In order to start the computation, Hadoop MapReduce will be effective if you are talking about huge amount of data, because in order to start, MapReduce has to do a job even before you get the first result. So you understand, if we are talking about small data, this is not cost-effective solution. But moreover, this is not the most important. Let's say that the most important, I think I had them in the previous slide. The most important operation which you have in Hadoop is put, get, and delete. The way the architecture is, you cannot insert immediately. So if you have to do banking operation, which are transactions, this architecture is totally unacceptable. Just this is an example. So we never can take the new stuff coming that this is just the end of what we have been doing for 30 years. Today, there is place for each of these technology. And this is one important point. I just have some important points that I want that you keep in mind when you dig in this amount of information. Up to here, any question? Because I'm rather going to go fast over there, so we have we have time for other. So the two components of Hadoop, as you have observed already, we are talking about not just about Hadoop distributed file system and MapReduce, which is the heart of Hadoop, the main component. We are talking about the Hadoop ecosystem, which has grown from the beginning, because every time company like Yahoo, Facebook wanted to do some application, they find hard time to work with MapReduce. Let's say MapReduce is just like the programming language, the very bare, basic programming language of Hadoop is to program in Java. So Java in this case is like the assembly language together with the requirement of MapReduce to do to develop any programming. And in order to do fast and the needed applications, company like Yahoo start developing additional tools. Yahoo developed Peek. Then Facebook, in order to solve their problem, they developed Hive because they needed something close to SQL to deal with the problem they have. And the Hadoop ecosystem start to grow enormously with a lot of components. So at first look, it's a little intimidating, the number of components. And each of them was developed for certain needs to solve certain problems. So along the way, many of these products, some of them have very limited application, let's put it this way. And at some point, the same way was claimed that Hadoop is just putting to end any relational database, any data warehouse. The same was the claim about SQL. This is the end of SQL. So neither of these we have to accept. And moreover, what happened in the last, let's say, in the last year, starting with the development of Hive, like it's not, let's say, ANSI SQL, but very close idea to the scripting language, and other companies develop similar product with different purposes. SQL is there. Why? Because this is very wide and very straightforward, let's say, language to deal with data. And again, is getting a lot of attention in the Hadoop ecosystem. So, going shortly, Hadoop is open source, a free distribution. This is the Apache Hadoop is open source free distribution under the Apache Hadoop distribution. That Apache is responsible for the distribution of this open source product. And open source was the other brilliant idea, which actually opened the wide door for this product. Open source, people can share code and can use and reuse and enhance. And the development in these 10 years of Hadoop was enormous. So all this open source, Apache Hadoop, was adopted by different companies to give, let's say, different distribution. What that means? If you want to get the free Apache Hadoop as a company, you can get it. You can do everything, but you will have to do all development work. You will have to have a good team of people to architect your needs on Hadoop and to maintain, update, and work on this. And this costs a lot of money because each of these people working in this team has considerable salary as a, let's say, skill with high claimed skill. So several companies, they find that they can solve this problem for many interested enterprise. One of them is Cloudera, is actually pioneering this. Cloudera was the first one to start providing not only the Apache Hadoop, but let's say the enterprise version, which I have presented here, which actually, if you want to contract the enterprise, they will give you not only the architecture you need for the problem you want to solve, but also they will provide you with all let's say technical support which you may need. And actually, you understand that this complicated architecture, you would need considerable technical support. So this is the Cloudera. very general. IBM had a little different idea because they saw this more, let's say, inclusive. Let's say, first of all, Hadoop, um, the first version, which were in the first 5-6 years, that was for totally batch process, the way the Hadoop was invented in Hadoop distributed file system. The way it works, you cannot work in dynamic or in data which are changing fast and constantly, because, as we said, we don't have an operation which is insert. You cannot insert data. You can, so that is just to tell you as a data, as understanding how data is managed, why the conception of Hadoop is not for stream of data. But then new products were developed, and IBM put in his conception, the distribution, all the data at rest and the stream data, and they have the InfoSphere beacon site and InfoSphere stream in order to deal with any data which a company can have, and also providing this to anyone interested with support. Interesting thing with IBM is, since they are, let's say, while Cloudera is a pioneer in what is Hadoop as technology, they are the first and the bigger one. Of course, they appeared two more, let's say, competitor to Cloudera, which are Hadoop distribution, which is Norton, Cartoon Norton, and MapR. So IBM is not in this team. IBM has slightly different strength and profile. IBM is the strongest thing in IBM is analytics, but they wanted, with the strong analytic they can provide, to have the best architecture, so the analytic on any type of data can be performed in the most, let's say, in the most suitable architecture. So that's why they jumped later to what is Hadoop, and the platform they present for big data is, let's say, more inclusive, because they explicitly include the way the analytics has to be done. So from point of view of our class, is of course very convenient we work in this type of conception, because ultimately the goal in this class is not the technology itself, is how to do analytics. So as a data scientist, data analyst, you are going to work in a team where you will give suggestion about the architecture, perhaps not as a data architect, but then they will be data architect, cloud architect, developer. They will provide the architecture in which you will be doing your analytical work. So that's why it appears the IBM conception more, let's say, suitable for the purposes of the data analytic class in big data. So I'm going to switch to the next slide, and you will see just the difference in 3 years. The main conception of IBM hasn't changed. What has changed is the technology. Hadoop is not anymore, let's say, the top big technology stuff, because it is good. Many companies have big investment, solve a lot of problems, has solved a lot of problems, and still is solving a lot of problems, and many companies will try to get return of investment on what they invested. But everything, it's not suitable for stream of data, for fast processing. Then a new product, Spark, has come in the last, let's say, 2.5 years, and we will have the opportunity to work with Spark in the following, let's say, not next week, after next week, after you finish with DashDB, doing, let's say, the most powerful tool we have right now in big data analytics. So according to this, IBM changed his conception. That one was for 2013, in 3 years. You can see again, very integral conception, but you see what is in the base? Spark Analytic Operating System, okay, which is very powerful machine learning library. And then on top of this, you have Hadoop NoSQL, but you have the whole conception, data conception for an enterprise. You see the advancement. So I want to point to two very important things you have to keep in mind, because we're talking about a lot of open source. The main components here are open source. This one, which is Spark Analytic Operating System, Hadoop, and NoSQL, all these are open source products. All the code is shared. You can go and find a code for anything. In addition to this, IBM put on its platform a lot of, which is the strength, the strong, let's say, the strong feature of IBM, a very strong analytical product, which are in their conception. So I just want to show you how important is a data analyst, maybe a data scientist, maybe just with, at this moment, let's say, at this moment, with R, Python, SQL, and Spark, you are done. Or with 3 of them only, okay? Why we have to keep with the technology trend? Because everything changes for better all the time, and sooner or later, the company in which you are working will be adapting this technology, and then the way you are going to do the analytics will change. And it's very important because actually these are not just investments. Any investor, any company look return on investment. And in our field, in data, when they talk about architecture for big data, they talk about bit for investment. That means what is the value you are going to get for each bit you store in your system, like Hadoop, Spark, and so on and on and on. So I'm not going to spend more time on this. You have plenty to learn. This is just one example of the platform. I think you can learn about this in the presentation we have posted in the classroom. I'm not going to spend time on this. I'm going to talk about, just briefly, about InfoSphere Big Insight, which is based on the open source Apache Hadoop, and has additional components which we are going to explore to manage data. Not all of them, because of the limit of the class. We are going to something which is accepted, at least at this moment, very important. You can have, you can manage your data from any source to what is Hadoop, which is big SQL. That's why the assignment is culminate, the study related with Hadoop will culminate with something, because you understand, in a class of 12 weeks, you don't have time to do in each of the 30, 40, 50 components which comprise the Hadoop ecosystem. So we pick up something which is very handy, which is big SQL, and always, and in addition, is very based to previous knowledge you must have as data analyst in SQL. So this is going to permit you from any SQL-based application, let's say for DB2, for your data warehouse, for Oracle data warehouse, to get, it's like an engine to get your data to Hadoop. It can use different storage, Hive, HBase, or distributed file system. The only thing I want to point here about BigSQL, you understand this is not ANSI SQL. They are differences, and these differences are based not because this is the IBM version, because if you go to the Hive or to Impala or to other versions, you will have also not 100 compliance with ANSI SQL, but very close, and your previous knowledge is very at hand to do. And it's very important, you get something, you get as a data analyst, as a data scientist, a tool to manage your data to big data, let's say, Hadoop or Spark, because BigSQL, either you can work with Hadoop or Spark, there are just very small modification, and we will be talking about this until the end of the class. So there are a lot of resources posted about BigSQL. You can read. This is just compared with two other products which are comparable with IBM BigSQL, which is the Impala from Cloudera and the Hive for NortonWorks. So they are very similar products. Again, we're talking about the two providers, which are the two distributors, Hadoop, Cloudera, and Horton. Their strong is Hadoop distribution. That is the strong of the company. While IBM, the IBM strong part is the analytics, and they have the Hadoop open source distribution also, so we can do both stuff with them. IBM actually, when implemented BigSQL, didn't use MapReduce. They use something which is very fast parallel processing, and they have better response, faster. This is just modified architecture in for the BigSQL. So mostly these are the main things I wanted to present here to you. I don't know if John, do you want to give your word? Maybe I forget something important, because actually we don't have time for much more. We have to go to the assignment, but it's very important. You just, whatever I missed, important point, please. Can you hear me? John Woo, are you here?
He might be on mute.
I'm unmuting him, but he's on mute. He's muting himself. I don't know. Maybe no, he's mute. And he does. John Woo, you're mute. We are not hearing you. Oh, here you go. Okay.
Yeah. So what do you want me to do again?
Just if I missed something important, if you want to make some comment. I know the next lecture is coming from you for Spark and all these things. We cannot do everything together, but at this point, if I'm missing something important.
I just want to tell you that like a Cloudera and Hortonworks are standalone the Hadoop solutions when you have a data center.
Mm-hmm.
But if you prefer using cloud computing, you may want to use IBM Bluemix or Amazon AWS or Microsoft Azure. So that's what people are doing. Also, if you want to use Windows Hadoop version, the Hortonworks and Microsoft Azure have good collaboration to present Windows version Hadoop solution. Yeah, that's what I just want to add.
Oh, very important. Thank you so much. Yeah, it's very important because, you know, that was, and we have to keep this in mind, because many companies already, they don't want to maintain any, let's say, information technology architecture in-house. They just don't want to care about this, and they are going to the cloud. And that is what I miss it, and it's very important. If you want to go to the cloud, you are not going to look for Hadoop distributor like Norton, like Cloudera, like Mapr. You just go to the cloud, either Amazon, Bluemix of IBM, or Azure. So wonderful. And the good thing is we have this solution actually implemented in our class. So I think any question here before we go into some clarification about the assignment? Question up to here. You have to unmute yourself to talk. No question. Elena, I know you have some instruction additional because some people had questions. You want me to pass the ball to you, or?
Well, yeah, sure. And there was something that I've seen in a conference. Well, I don't want to call it disappointment, but some people may have been trying to access the system from the work network. Well, unfortunately, for numerous security reasons, some employers block certain sites. Like, personally, I cannot access the sandbox from the work computer, so you would need to be on your home network, but not on a federal network or anything like that. That won't work because the employers block for security reasons.
And I cannot pass the ball to you.
Oh, you cannot?
No, I'm going to do this administratively. Yeah.
Yeah, well, that's okay. While I'm speaking.
No, can you drag it? I think they changed it again, the setting.
You cannot drag it. Nope.
No, you remember before everyone was able to steal it from me, and now no one. Okay, I'm going to give you. No, it's not working.
Wow. Oh, it could be in the settings somewhere.
Okay.
But, yeah.
Okay. Okay, I got it.
Okay. Another.
Oh, they changed this totally. They changed. Now it's 3-step process.
Whoa.
I even don't remember how I did it. I guess I can repeat next time.
Yeah. So now I have to do something to share. And what do I do to share?
You don't have the button of share? You must have it on the top.
I see your screen still.
Yeah, you see, because you have to go on top and click on share and share.
Oh. So that's different. Okay, share my screen. Got it.
Share. Okay, you got it.
Okay, there we go.
They changed it totally, everything.
Yeah. So basically, for the first part of the assignment, you guys just go through the tutorial that's posted in the course content, and there is a script for the tutorial. So you use that script for the first part. For the second part, you need to create your tables. But before you do that, it's very important. You need to decide what exactly you want to do. What information is your database going to store? So basically, you start from a narrative. You describe something similar to what I gave an example in the conference, where, for example, I just say, suppose that my database wants to track the registration system. And I'm going to have a student, and information about the student is going to be first name, last name, student ID, and the date when the student was admitted. Then I'm going to have a course information. What am I going to track about the courses? It's going to be course number, course title, perhaps maximum number of seats. Well, I'm just making it up, right? And then I'm going to have an enrollment where I'm going to track this student is enrolled in that course, right? And I'm going to track how the student was registered. Was it self-registration or was it registered by advisor? And I'm going to track the grading option and so on and on. So you basically write it, what my database is going to store and who is going to benefit from it. How will the end user, who is an end user, why, what's the purpose? And after that, you start designing, creating tables. First, you have to have in mind what you want to do. Now, something else that came up is that all of you have database, when you create a database account, right, all the tables that you create, this is your schema. Nobody can access the tables that you created unless somebody is super admin and has elevated permissions, so to speak, right? So, for example, if Ida creates a table, right, John Woo cannot access it. So basically, it does not matter if another user has a table with the same name. This is her table and this is your table. So, like if you go over here, that's what I mean. I'll show you. If you go to Explore Database, right, you can see that there is another user who created the same table as one of your tables for part one, right? But the thing is, this user is it's a training user. Those tables are used for training, right? So basically, even if you look at it, to open it, right? Even though the tables that you are creating for the part one have similar name, the structure is different. So those tables, this table right here, it belongs to another user. That's not the same table that you created. So it's just something that came up today. Okay, so how do you know which tables you created? What you can do here is, see here, all tables. What you can do is see the schema. Schema is going to be your username. You need to search here for your username. So I'm going to go in here, filter, right? Let me delete. And what I'm going to do here is that I'm going to say rules, and I'm going to put owner, right? Contains, and I'm going to put mine. Right? And I'm going to go here, say filter. And what it will do, it will show the tables that I own. And I can only query the tables that I own, plus anything that's in the training schema. But if I try to access something that, not mine, but something that's in the training schema, I have to prefix that table with that specific username. So, see this, when you run a script that's posted in a conference, right, that table is going to be sitting on your account. It's not going to be touched by anybody who has a different username. So that's something very important to keep in mind. Another thing is that, as you may or may not have seen this before, it's a case on every database. If we're working on something, then you left your desk, perhaps to have a nice dinner or lunch. After a certain amount of time has elapsed, after the session is idle, it's gonna time out. It's just like that in every database. So then when you're trying to go back in, you might be seeing the errors that you're unable to access the table or something like that. It's because your session timed out. What you're gonna need to do is you're gonna need to log back in, and that's all. That's the solution. I ran into it myself here, so. And unfortunately, there is no explicit error message saying that your session timeout, but just keep in mind that what happens, okay? It just came up today, so yeah. And another thing is that that's a big one. I always try to emphasize it. Do not type the code in Microsoft Word. Do not do that because it introduces the characters that SQL does not like. And one example would be the quote, the single quote from Microsoft Word. And once you introduce it, it's very difficult to fix the code. Very difficult. And I've been repeating it all the time, but every semester, unfortunately, somebody copies code to Microsoft Word. It's not going to work this way. So use the Notepad or the TextPad or Notepad++. That one should work. Okay? So, so just remember this. Explore, right? Explore database. That's where you can see the list of your tables, but you have to filter it out by your username, right? And if you go to Develop SQL Editor, that's where you're going to type your code, right? And what you can also do is here is validate. So it will show you if there is a syntax error. Another thing to keep in mind is that patience is the key. So suppose that you're running something on script, do not terminate the process, just let it run, right? Suppose that I made a mistake, oh my God, that's not what I want to do. Let it run, just let it finish and then fix it. Because when you're trying to stop something, it does not really stop. It doesn't really stop. It kicks on another process in the background to stop or to undo. So do not do this. Or I've seen some people hit run multiple times, it starts another process, and there's gonna be issues later on. Okay, so nobody's gonna do that, hopefully. And you can copy and paste, and I would recommend saving a copy on your local copy. I would recommend doing that. All right. I guess anything that I may have missed. I was trying to point out what not to do because I've seen people do that, and that's sad.
No, let's see if there are questions of any kind. Could be with the assignment, could be with what we are learning.
Can you hear me?
Yeah, we can hear you.
I have a question. The assignment, the part one of the assignment, which is the part you gave us the script for, do you want us to show every step we went through running that script, or you only want?
I need the script. I need a copy of the script because there is a
everything
big. Well.
Want us to show everything? I mean, like snapshot of the stuff we did on the first part.
Well, well, the thing is, a big chunk of the points is to write a script, and I need to have a script. How else are you going to be evaluated? I need to have a script.
No,
I need to have a screenshot.
what I'm saying is, you know the first part of it, you already gave us a script to run.
For part two, it's your script. For part two, is your script.
That's what I'm asking. The part one, you don't want to see it. We don't have to show it, right?
Not for part one, just for part two.
Okay, good. That's what I want to know. So we don't need to show anything in part one, just part two.
For part two, yes, I need to have a script because the big part of the points is for writing the script.
Yeah, sure. I mean, I know. Yeah, I just want to clarify it so that you don't have too many things at the same time, like showing the part one and the part two. Okay, good.
That's okay. Did I answer the question?
Yes.
More questions?
Hi, I have a question.
Yes.
Yes.
Can you give a little more detail about what is expected in the part one summary essay?
Oh, that's about the comparison of structured versus unstructured data. That's what it is.
Right. Should we, are we to give our impression of using it on that specific exercise, or should we go into detail about the steps that we performed for the exercise?
Well, that one is basically the difference between structured and unstructured data.
Okay.
Well, it's more like cumulative.
Okay. Thank you.
Well, because when we're working on this assignment, we cannot just forget everything that we've done in the first two assignments. I mean, did I answer the question?
Yeah, I just wanted to know, you know, like how long our summary should be. Is it?
It's
I don't know how much detail or how general it should be in our response.
Okay, let me give general a suggestion here because I see this question coming a lot. Just use your judgment, like suppose you are not in the class, you are already at work, you are almost at the end of the program. So when the statement says, give your impression, what you have learned, and so on and on, don't try to look for a pattern, what I'm looking. We're looking here, the real data analyst, your thoughts. So I don't want to give for this specific thing, let's say a box, I want this. When you see certain bullets and issues, which are like, these are guidance. But what we are looking in this class is you go out of the box, and the bullet point are just guidance, which are like the key points you should not omit. But you have to go out of the box, and if I'm asking you, run this and give me your impression, what you have learned about this and about structured and unstructured data, which is actually what we are asking for part 1. Don't try to get more, just use your judgment out of any box. I don't want to give box here what I'm looking. I don't know if you like this or not, but I think this is the most helpful thing for a future data analyst. You have to think out of the box and whatever you interpret. I mean, I understand that many expressions, we talk a lot about this in the first part of the course, this English language. When I give a sentence, they can be different interpretation what I intend. But the sentence in the description of the assignment is just the base. Don't try to wrap this sentence in a box. That is my suggestion. I don't know if I explained what I really want. But if there are not some points which are saying this and this and this, which are like a guidance, you are free to go out of any box and give everything you have learned from this. Because maybe you learned not only doing this step-by-step activity, but also you learned something because you read, you digested still things which you read before doing this, and you connect them with what you are doing right now. And these are the things which, let's say, we as an instructor, we are looking from you as a student, what really you learned, and don't put it in the box. I don't know if this makes this easier or more complicated. Ma'am?
Yes. I was just, wondering if it's in this kind of the same way that we would do a discussion question.
Yeah, this is free question. It's open. Yes, it's open question. Totally open question. The way it's formulated is totally open question. And I want to see different perspective. That is the most important thing. There is no box wrapping your question or your answer.
Okay, thank you.
Mm-hmm.
And even on SQL, how you can go beyond is that you can create the constraints, you can create the indexes, right? There's a bunch of stuff you can do here. So you can create your own functions if you'd like. It's not required, but if you want to learn more, go ahead. Yeah.
And here it's not only about more, and it's the way you present. There is no certain way we want to wrap your answer. I mean, I don't expect to find two similar answers in the assignment when we are grading this assignment, because this is something you run, but then you as a data analyst, you give your interpretation. So I don't expect to find two identical answers, two similar answers even. What I want to find is some guidance you have in the rubric. Try to follow the guidance. The guidance are the key points which have to guide you, and you should not, let's say, this is guidance. It has to be around this, should be something. More questions? More questions. I don't know why I feel like people have not started working on this, and I think this work even with minimum without going above and beyond, like Elena suggests to do that and the other. Just doing the minimum is time consuming, so I don't think there is much time for this. I would be happy to get already assignment and to release the next one.
Yeah. And also because another reason for not wait until the end, because there is a there is a risk of getting SQL errors. So I don't want anybody to be spending the whole day on resolving not simple, but I don't want anybody spending the whole day on resolving the query error, so to speak. So you need to allow yourself sufficient time for debugging or for anything like that. Yeah.
Yeah, that is a suggestion. Planning is very important.
Yeah. So you just write down sort of like note for yourself a set of risks. Like for instance, there is always a risk of system downtime. Always there is a risk, right? There is a risk of running into the syntax errors and so on. You need to schedule this assignment. I would say total 15 hours to complete.
Yeah, it's 15-hour assignment. That's why is the portion of the final grade. Everything is calculated. It's not just simple like this. Yeah.
So if you may not have started, it means that you'll need to be working on it for like 4 hours per day in the remaining days. That's what I think. Well, approximately. Yeah.
Well, if there are not more questions, I will be happy to see very good report about your experience with BigSQL, and if not, and then moving to other more exciting stuff. If no more questions, I will stop recording.